Rational numbers. Properties of rational numbers. We've understood what is closure property, commutativity, and associativity of the rational numbers. Now, we'll be looking at the role of 0. What happens when you add 0 to a number? Let's check for whole numbers, integers, and rational numbers. Add 0 to a whole number. 4 plus 0 is equal to 4. 0 plus 96 is equal to 96. The number remains the same. Add 0 to an integer. Minus 4 plus 0 is equal to minus 4. 0 plus minus 6 is equal to minus 6. The number remains the same. The sum of a rational number and 0 is the same rational number itself. 0 plus 6 upon 13 is equal to 6 upon 13. 4 upon 7 plus 0 is equal to 4 upon 7. 0 plus 5 upon 9 is equal to 5 upon 9. 6 upon 11 plus 0 is equal to 6 upon 11. 0 plus a upon b is equal to a upon b, where b is not equal to 0. Therefore, 0 is called the identity for the addition of rational numbers. That means when you add it to a rational number, the rational number remains unchanged. The product of a rational number and 0 is 0. A upon b multiplied by 0 is equal to 0, where b is not equal to 0. You can easily verify this. Minus 5 upon 9 multiplied by 0 is equal to 0. 0 multiplied by 8 upon 7 is equal to 0. 3 upon minus 11 multiplied by 0 is equal to 0. So, we've understood what the role of 0 is. Now, we'll be looking at the role of 1. Let's check for rational numbers and find out. The product of a rational number and 1 is the same rational number. You can easily verify this. Minus 5 upon 9 multiplied by 1 is equal to minus 5 upon 9. 1 multiplied by 8 upon 7 is equal to 8 upon 7. 3 upon minus 11 multiplied by 1 is equal to 3 upon minus 11. The product of a rational number and 1 is the same rational number. That means a upon b multiplied by 1 is equal to a upon b, where b is not equal to 0. 1 is called the multiplicative identity for rational numbers. That is because when we multiply a rational number by 1, we get the same rational number. So, we've understood what the role of 1 is. Let's check out the negative of a number. You know what the negative of an integer is. The negative of 3 is minus 3. The negative of minus 4 is 4. It's basically the additive inverse. When we add an integer to its negative, we get 0. Rational numbers have negatives too. When we add a rational number to its negative, we get 0. So, the negative is also called the additive inverse. Rational number 11 upon 36. The additive inverse is minus 11 upon 36. Rational number minus 7 upon 12. Its additive inverse is 7 upon 12. Rational number 6 upon 13. Its additive inverse is minus 6 upon 13. So, we've understood what the negative is. Let's check out the reciprocal of a number. Rational numbers have reciprocal. If a upon b multiplied by c upon d is equal to 1, then c upon d is the reciprocal of a upon b. You can easily find the reciprocal of a rational number by flipping the numerator and denominator. Remember, 0 has no reciprocal because 0 cannot be in the denominator of a rational number. Find the reciprocals of these rational numbers. 4 upon 7 gives us 7 upon 4. Minus 3 upon 4 will be minus 4 upon 3. Minus 2 upon minus 9 will be 9 upon 2. 1 upon 7 will be 7 upon 1 is equal to 7. 12 upon 19 will be 19 upon 12. 13 will be 1 upon 13. Answer these questions. The reciprocal of a rational number is a rational number. Does 0 have a reciprocal? No. What is the reciprocal of 1? 1. What is the reciprocal of minus 1? Minus 1. Is the reciprocal of a negative rational number also negative? Yes. A reciprocal is also called the multiplicative inverse. Why is that so? Because when we divide a rational number by the other, we take the reciprocal of the divisor and convert the division to multiplication. So, we can take the inverse to multiply. That inverse is the reciprocal and the use of it is multiplication. Hence, reciprocal is equal to multiplicative inverse. Get it? When we divide a rational number by 1, we get the same rational number. 8 upon 14 divided by 1 is equal to 8 upon 14. Minus 16 upon 70 divided by 1 is equal to minus 16 upon 70. When we divide 1 by a rational number, we get the reciprocal of the rational number. 1 divided by minus 6 upon 20 is equal to minus 20 upon 6. 1 divided by minus 16 upon 9 is equal to minus 9 upon 16. What's additive inverse? It's the negative of a number. What's multiplicative inverse? It's the reciprocal of a number. When you add a number to its additive inverse, you get the answer as 0. When you multiply a number with its multiplicative inverse, you get the answer as 1. Remember that properly without getting confused. Kidding, of course you won't, you're smart. So, we've understood negatives and reciprocals. Let's check out the negative of a number. Let's check out the last property, distributivity. Distributivity is actually distributivity of multiplication over addition. It's easy to understand by just looking at it directly rather than just explaining in theory. Well, most of mathematics is that way. You just have to get it properly. Then it's all easy breezy. Look at this expression. We have a bracket, so we solve that first. Then we multiply and get the value. 5 upon 7 plus 6 upon 15 into bracket multiplied by 2 upon 5 is equal to 75 plus 42 upon 105 into bracket multiplied by 2 upon 5 is equal to 117 upon 105 multiplied by 2 upon 5 is equal to 78 upon 175. Now, look at this expression. We do the multiplication first and then the addition, and we get the same value. 5 upon 7 multiplied by 2 upon 5 plus 6 upon 15 multiplied by 2 upon 5 is equal to 2 upon 7 plus 4 upon 25 is equal to 50 plus 28 upon 175 is equal to 78 upon 175. Interesting. Let's get to the bottom of this. This is something that is going to help you a lot in mathematics that you'll do for years to come. We just found out that these two expressions mean the exact same thing. Basically, what has happened here is that when we open the bracket, that multiplying factor outside the bracket goes to each term inside the bracket. What if we had a subtraction inside the bracket instead of addition? Doesn't matter. It would still work. 5 upon 7 minus 6 upon 15 into brackets multiplied by 2 upon 5 is equal to 5 upon 7 multiplied by 2 upon 5 minus 6 upon 15 multiplied by 2 upon 5. Now, you may wonder, does this hold true for multiplication? Well, we know that whatever is multiplied to the bracket applies to each term inside the bracket. So, is this true? 4 upon 5 multiplied by 3 upon 7 into brackets multiplied by 2 upon 3 is equal to 4 upon 5 multiplied by 2 upon 3 into brackets multiplied by 3 upon 7 multiplied by 2 upon 3 into brackets? No! We said each term inside the bracket. Inside the bracket, we have 4 upon 5 multiplied by 3 upon 7. This is one term. Terms can be separated by addition or subtraction only. If there are numbers separated by multiplication or division, they are still one term. This is the mathematician's way of showing distributivity of multiplication over addition for rational numbers. A upon B plus C upon D into brackets multiplied by E upon F is equal to A upon B multiplied by E upon F plus C upon D multiplied by E upon F, where B is not equal to 0, D is not equal to 0, and F is not equal to 0. Did you understand the different properties of rational numbers? Yes.